Okay, we just had a good break. Yes, okay, you just had a 2-minute mental break. All right, example 7. Okay, sketch the graph y equals to this. Do we all know what this means? The modular sign? Yes, yes. Okay. This is quite a tough example actually. Now we need to sketch this. Use your graph to deduce the least value of this. Now we need to sketch this. Now, even your GC not upgraded, you can also do this together, okay? Because this one only the latest PC edition OS. Okay, so can we sketch this on using our GC? Yes. Okay. You can, in order to bring up the modular sign, look here, alpha window 1. If you want to bring up, oh dear, this pen is not working again. Or is it? Oh, it's working, it's working. Okay. Okay, alpha window 1 to bring up the modular sign, and then you type this into your GC. I don't want to show it to all of us. I think we are all able to do it. Okay? Okay, you type all these. You know how to type X. It's only this one that you may have a slight problem. Then key in the equation of the graph. Now, it's interesting now. When you press zoom 6, you realize that it looks like you think it's a curve, but actually it's not a curve. It is made out of 3 straight line segments, like that. It is actually, let me zoom in a little bit more. Yeah, it is actually 3 segments, like that, like that, like that. Can? You all tried it? Yes? Can get? Good. Now, what is so special about this? We can zoom in a bit nicer. Let's try the suggested window settings to change it. You can set it from X minimum. This you can change. Set your X minimum to be this. Your X maximum to be this. Y minimum to be this. Y maximum to be this. Then you can see a nice looking graph. How do you go to X minimum, Y minimum? You can click window. Okay, window. You can see a nicer looking graph. Now, they get a nicer looking graph. Okay, yeah. All right. We need to identify. Oh, sorry. Where's here? If you look carefully, what is most important about this kind of graph are these points. These are important points. These are points we call vertices. Alright? These are the vertices. These are important points. Okay. What are the x coordinates of these vertices? Can I say this first? Sorry, maybe I scrolled. Like this. Let's take a look at the equation. This one. The vertices can be found like this. I give you a simple example. If y equals to mod x plus 2. So the graph will look like this. Okay, you sketch another graph, you sketch y2, you realize the graph will look like this. This point, I can be very sure this point is minus 2, 0. The x coordinate at this point is minus 2. I can be very sure. Why? Because because the mod sign works like this. The mod sign works like this. If the expression in the mod sign is positive, then taking mod won't have an effect. We agree. Correct? Imagine you substitute like 5. You put x equals to 5 here. Then you get 7. Mod 7 is still 7. Wouldn't make a difference. So you from minus 2 all the way to 5, 6, 7, 8, 9, 10, you put inside here, it wouldn't make a difference. The graph will look like an x plus 2 graph. This part will always look like x plus 2 graph. So far, so good. The moment you substitute something slightly smaller than minus 2, then this expression inside will change, will become negative. Correct? It will become negative. Now, therefore, minus 2 is a critical point where it changes sign. Does it make sense? Negative 2 is a point where this thing changes. Therefore, definitely the vertex is at when x equals to -2. Make sense? So, I give you another example. If this is, sorry, if I have y equals to mod y equals to mod 2x plus 1, where do you think is the vertex? What is the x coordinate of the vertex? What do you think? X equals to minus half. Yes? Make sense? Because x equals to minus half is the value when it changes sign. Got it? When it changes sign. Therefore, you take a it changes sign, changes direction. So, you look at this graph. Example 7. We have 2 mod sign here. Where would it change sign? It will change sign at x equals to minus half and x equals to 3. So very clearly, I can be very sure, you see here these 2 points, I can be very sure that this x coordinate is definitely minus half, this y coordinate, and this x coordinate is 3. I am very, very sure. So that is why on your next, on the solution, here, you can be very sure that x equals to minus half. Now, I don't want to say too much on how to calculate this rule. In fact, you can use your GC to calculate. You can either by hand or you use GC. If you have sketched the graph on your GC, you can actually substitute x equals to minus half into the GC and the GC will help you calculate. So, yeah, if you use by hand, y equals to, you sub minus half, you will get your mod 2 minus half plus 1 mod plus mod minus half minus 3 equals to 7/2. Or you can use GC. Use GC to find directly. Okay, you can actually use GC to find. You can skip this step. If you find use GC directly, you can get 7/2. All good? Yes? Now, I shall not go through how to find this y. I think you can do it on your own. You can get a 7. Or you can use GC directly, you can get 3. So which means you can, this graph, whenever they ask you to sketch a graph, this is not useful. It's not useful because you actually have not included the important points, which are your vertices and your intercepts. Okay, so there are a few points that we need to label. Alright? If you look back at the question also asks us to sketch from let me see. Sorry. Let me go at the question. Okay, you are supposed to sketch. Okay, like that. So you need to include a few things. You need to include this one that we have found. This is minus half. Minus 0.5 because it's written minus 0.5. Minus 0.5, sorry. Minus 0.5. 3.5. And this vertex is 3, 7. And the y-intercept is 4. This one is 0, 4. And I just taught you how to find the intercept. All okay? Can? Now. Okay, can? All good? Yeah. I just said you can actually use your GC to calculate. So I don't want to go through this one. You can do it on your own. You can read on your own. Okay, let's finish off the second part of the question. Am I going through too fast? All okay? Okay? Can I? Good. Okay, second part of the question. Let's finish this and we'll stop here. I promise we'll stop here. 1 minute more. Okay. Use your graph to deduce the least value of this. Let's take a look. There is a k here. You want to find the least value of k plus something. Can we take a look at the graph now? If I ask you, can you have attention please? What is the least value of this one? Without the k, what do you think the answer is? I repeat one more time. My question is this, what is the least value of 2x plus 1? Oh, this pen is plus x minus 3. Without the k, what do you think it is? 3.5. Makes sense? Because you look at the graph, no matter what you add, you sub in the lowest value is 3.5. So now I add a k. So clearly, you know the answer. Correct? The minimum point of this is just a translation of k units in the positive y direction. So the minimum point must be minus 0.5 and a 3.5. Oh God. It's telling me to stop. 3.5 plus k. So therefore, the minimum value is 3.5 plus k. Okay, good. We stop at periodic function. We'll go through periodic function next week. Thank you.